So today we'll be looking at question 30 from the 2015 AMC Junior Division, so Australian years 7 to 8, and it's worth 10 marks. So let's take a look at the question. In a stack of logs, each row has exactly one fewer log than the row below. With 9 logs, the tallest possible stack is shown. So this stack right here, it's the tallest possible stack. With 2015 logs, how many rows are there in the tallest possible stack? So in the tallest possible stack, how many rows are there? So we'll be looking at this question today. So here's the question. So we'll start off. So if you can see with the logs, you can actually double them to make something like this. Here. And this is quite important because we can do the exact same thing to 2015, to number 2015 with 2015 logs. Because this is the 9 stack doubled. So we can do that with 2015. So let's do that. So 2015 times 2 equals 4030. So 4030. So what we can do is we can take the prime factorization, the factors of this number, not essentially just prime. An easy way to do that, because 4030 is 2015 times 2. An easy way to do that is to just multiply the factorization of 2015 by 2. So we can do that right here. Okay, so 2015 can be divided by 5, which will give us 403. And 403 can be divided by 13, which can give us 31. 13 is one of 403's only factors. And 31 is a prime number, so 31 can just go here. So these are the 3 factors of 2015. We just times that by 2, so 430 equals 2 times 5 times 13 times 31. So because we want to find the tallest possible stack, and a stack of 9, for example, can be done as 1, 2, 3, 4, 5, and 1, 2, 3, 4. That's 9. That's a possible stack of 9 right there. But it's not the most efficient because, again, it's not one that is the tallest, which is what we're aiming for, as it says. How many rows are there in the tallest possible stack? So we can just go through the options. So because we've got this starter here, 2 times 5 times 13 times 31, we can start with 4030 equals 2 times 2015. Remember, we're still referring to this trapezium right here for a stack of 2015. Another option here we could do is 5 times 806. Which definitely increases in height, which is what we're looking for. Let's see if we can increase more in height. So we can by multiplying 5 by 2, doubling it. to make 10, and halving 806, which is just 403. And then looking at this again, we've got 13 we can do here, times 310, because it's 2 times 5 times is 10, 10 times 31 is 310. And you can just double 13 to make 26. 26 times 165, which is half of 310. Sorry about that. It's actually 155 instead of 165. And then obviously you got this 31 here, and then 10 times 13, which is practically what we did with that. So 31 times 130. And then you can double 31 and half 130 to make 62 times 65. You can't do anything more with this to equal the same. Now when we think about it, in a triangle number, or in a triangle made out of dots, of course, the row with the most dots is at the bottom. And you're not going to have dots floating in the air like that, for example. Because if we did 65 at the 62 at the bottom, 62 dots at the bottom, and at 65 rows of them, the triangle or trapezium in this example would practically go like that in a way, which is like hanging dots in midair, which is not really possible. So what we want to do is we want to have 65 dots at the bottom and 62 rows of those, which is the tallest possible one, because as I just said, you can't have 62 dots at the bottom and 65 rows on top. So the tallest stack is 62, has 62 rows, and the bottom row being 65. So the answer should be 62. Which it is.